Hello, first class Java developers. My name is Aakash Arora, and this is the first video of Java Evolution. And I am about to take you on a 2-hour adventure through the birth of one of the most influential programming language in the history of computer science. And so, picture this: it's 1995. Netscape Navigator is the cool kid on the block, and Windows 95 just launched with the iconic startup sound. And somewhere in California, a team of brilliant engineers is about to change the world of programming forever. They called it Oak first, then Java. So, Java 1.0 wasn't just a programming language, it was a revolutionary concept. Write once and run everywhere. Think about that for a minute. In 1995, if you wanted to write a software that worked on different computers, you basically had to rewrite it for each and every platform. But Java said, hold my coffee, and introduced the Java virtual machine. And suddenly, your code could run on Windows, Linux, Mac, and everywhere. So, let me show you a very simple Java program, but which is historically very significant code. Every single word used in this program has an importance, very much importance. Look at this beauty. Simple, elegant, and it worked the same way whether you are running it on a PC or a Mac or a Unix or a Linux. The syntax was familiar to C and C++, but without the memory management nightmares that kept developer awake at night. So Java 1.0 came with about 200 classes. By today's standards, it is like nothing. But back then, it was revolutionary. You had your basic features like some IO capabilities and networking support and AWT, and this was something that got created in Java 1.0. So let me show you one very old Java program for AWT which would create a button. I'm sure you might have never seen this type of code, and most probably you will never, but just take a look. This was mind blowing in 1995. You could create a button in a window and it would look native on whatever platform you are running it. So the network capabilities were also a game changer. Before Java, network programming was like performing surgery with oven mitts. Java made it a little more present. So I'll show you one more example of networking that happened at that time. Why? Just because it worked. No wrestling with the platform specific socket libraries, no deciphering cryptic error codes that seem to be written in some ancient Sumerian language. Java's networking was clean, intuitive, and cross platform. But Java 1.0 was not perfect. Oh no, it had its own quirks. The AWT was functional but limited. Exception handling was there, but the hierarchy was still being figured out. And performance, yeah, it was slow for that time also. But the garbage collector was also a blessing and a curse. No more manual memory management, which was fantastic. But sometimes it would kick in at the most inconvenient moment. So just imagine you are running a time critical application, and suddenly Java garbage collector decides that this is the cleaning time, and your application would freeze for some milliseconds while Java is just tidying up the memory, and but it would leave users wondering if the computer had given it on the life. But here is one thing about Java 1.0. It was ambitious. It was not trying to be just another programming language. It was trying to solve some very fundamental problems of software development. Which were platform independent, memory management, networking, object oriented designs, all wrapped up in a language that was approachable for developers who were coming from C or C. So, object oriented features were solid. You had classes, you had interference, polymorphism, encapsulation, all the sol pillars were there. This is also one of a many important topic for in interviews. So this was the example of polymorphic behavior. So polymorphism was also elegant and very powerful. You could write code that worked with abstract concepts, and the actual implementation details were handled at runtime. It was like having universal remote control that somehow knew how to work on devices that haven't been invented yet. It's a big statement. Now let's talk about a little bit about threading. So threading was also one area where Java 1.0 showed its ambition. So multi-threading traditionally had been domain of system programmers who enjoyed pain, but Java tried to make it accessible. So did you see this example? This was also revolutionary for its time. You could create concurrent programs without dealing with low level thread management, mutexes, semaphores, and yeah, of course, Java's threading models had its own complexities and pitfalls. But for that time, it was a very huge step. Now, let's talk about exception handling. So, the exception handling model was another standout feature. Instead of relying on error codes and return values, Java introduced a structured way to handle exceptional conditions. Just take a look at the simple example from old time. You see, this try catch mechanism was so much cleaner and checking return codes after every function. It separated the happy path of your code from error handling, making it both easier and readable and maintainable. So now let's talk about applets. If when some legacy applications, if somebody is supporting, we still have applets in use currently. Okay, so if you weren't there in 19 mid 90s, you might not be able to understand the sheer excitement around Java applets. The web was mostly static pages with maybe some animated GIFs if you were lucky. So the Java applets came along and suddenly you could embed interactive application directly in web pages. So let's take a small example of applet also. So here you would embed this in an HTML page with a applet tag, and boom, you had an interactive content running in your browser. It was magic. Except the magic sometimes took 5 minutes to load, and occasionally it would crash your browser also. But for that time it was also working and it was amazing. So now Applet promised to transform the web from document delivery system into a platform for in applications. And for a while, it looked like they might succeed. You had games, educational tools, data visualization, interactive demos all running on a web browser. It was the early vision of what could eventually become modern web application, except with more security warnings and plugin installation prompt. The Java 1.0 API was surprisingly comprehensive for its first release. So you had the Java Lang package with some fundamental classes like object, string, system, where we see the system.out.println basically, and the util package with basic data structures, having some collections, some vectors and hash tables, enumerations, things like that. So, yeah. So, vector and hash tables were also workhorses for early Java programmers. They weren't perfect. Vector was synchronized, which made it slower than necessary for single threaded use, and hash table had similar issues, but they got one job done. The API design was consistent and logical, which was breath of fresh air compared to some of the C libraries of that era. String handling in Java 1.0 was both a blessing and a source of confusion also. Here it makes also a very important question for the interviews. So string were objects not of primitive types, but they meant which meant they had methods and proper memory management, but they were also immutable, which caught many C programmers off guard. So let's see a one example also of strings. You see the distinction between e double equals and dot equals for string comparison probably caused more debugging sessions than any other single feature in the early Java. Coming from C, where string were just a type of array of characters. The concept of string objects with identity separate from their content was revolutionary but confusing. Performance was the elephant in the room for Java 1.0. The promise of write once and run everywhere come with a significant performance cost. Java bytecodes were interpreted, not compiled to native machine language, which meant it ran considerably slow than equivalent to C or C++ program, which led this famous criticism that the Java was great for programmers but terrible for its users. But here's what critics missed. Java 1.0 wasn't just about performance, it was about productivity, maintainability, reliability, and yes, your Java program might run a little slower than the earlier equivalent C program, but it was also much less likely to crash with a segmentation fault, corrupt memory, or it would behave differently on different platforms. The development tool available for Java 1.0 were basic by very basics by today's standards. You had the Java C compiler, the Java interpreter, the Java docs for the documentation. IDEs were very primitive or maybe non-existent. Most developers used to use a text editor or command line tools, Vim maybe. Debugging was often done with print statements because debuggers were either unavailable or unreliable. So let's take a very simple example of a calculator. So as per this example, you would compile it with Java C calculator.java, which would produce calculator.class. Then you have to run it with Java calculate. You have to run it with Java calculator command. Simple, straightforward, and it worked the same way on every platform that had a JVM. The security model for Java 1.0, especially for applet, was groundbreaking. The Java sandbox prevented applets from accessing local file systems, making network connections to host other than one they came from and executing native code. This was revolutionary for web security, even though it was sometimes overly restrictive. So let's see an example of applet security also. So this applet could respond to user interaction and display information, but it could only read files from your hard disk, send your personal data across the network, or install malware also. The security model wasn't perfect at that time, and the vulnerabilities were discovered over time. But it was a huge improvement over the wild west of the native code execution that preceded it. Database connectivity in Java 1.0 was also limited. JDBC was not available at the time, so database access was typically handled through vendor specific APIs, maybe some JNIs calls to native database libraries, etc. This was one of the areas where write once and run everywhere break its promise. Now you needed to connect to a database. You had you had to write a platform specific code, right? So the IO systems in Java 1.0 was comprehensive but sometimes cumbersome. Everything was based on streams, which was conceptually clean, but sometimes very verbose. Let's see one examples also of IO systems. So, the layered approach to IO was powerful but required understanding the relationships between different stream types. You would often see code that wrapped a file in input stream in an input stream reader, which was then again wrapped in a buffered reader. It was like Russian nesting dolls, but for data streams. Memory management was one of the biggest selling points. No more malloc, calloc, or free memory. No more memory leaks from forgotten deallocations. No more crashes from accessing freed memory. The garbage collector handled all of it this automatically. So now let's take another see another old example for how the memory was getting managed at that time by the garbage collector. You see this example? This was very liberating for developers who had spent years tracking down memory leaks and debugging heap corruption issues. Of course, Java collection came with its own set of challenges: pause times, unpredictable performance, and the need to understand object lifecycle. But it was still a massive improvement. The reflection capabilities in Java 1.0 were limited but present. You could inspect class information at runtime, which enabled some very powerful programming techniques. So let's take an example of reflection also in Java. So now reflection opened up the possibilities for frameworks, different tools, and dynamic programming techniques that were not possible as in statically compiled language. This was the foundation for many enterprise application frameworks that would emerge in the later years. And so now let's get fast forwarded to Java 1.1. So this was released in 1997. If Java 1.0 was the ambitious first draft, Java 1.1 was the okay, we have learned something types revision. It addressed many of its limitations and pain points of the original release while maintaining backward compatibility. The most significant addition in Java 1.0 was the introduction of inner classes. This feature allowed you to define a class within other class, creating a more sophisticated object relationship. So let's see a example of inner class. So you see this example. Inner classes enabled more sophisticated design patterns and better encapsulation. There were powerful, particularly useful for event handling and callback mechanism, which was which became crucial as Java moved beyond simple applications. The event model got complete overhaul in Java 1.1. The original event model was functional but clunky. Java 1.1 introduced the delegation event model, which was more flexible and powerful. So, now let's talk about the Java beans. Just take a look at this small class. So, Java Beans became the foundation for many Java framework and tools. The consistent naming convention made it possible to build generic tools that could work with any Java Bean, leading to visual development environment and component libraries. So now talk about JDBC, the Java Database Connectivity API was another major addition in Java 1.1. And for the first time, Java had a standard way to connect to multiple different databases. Let's see a small example. This might you might have seen this similar code somewhere in your old applications of JDBC. So again, so JDBC was revolutionary because it provided a consistent API across different database vendors. You could write code once and switch between Oracle, MySQL, Postgres, or any other database that had a JDBC driver. This was very huge for enterprise development. Now let's talk about serialization. So serialization was another main feature which was introduced in Java 1.1. This allowed you to convert Java objects into a stream of bytes that could be stored or transmitted, then reconstructed later again. So just see a small example of serialization and deserialization. So serialization enabled persistent storage, distributed computing, and deep copies of object. It was particularly important for RMI, which is Java's remote method invocation system, which allowed you to call method on objects running in different Java virtual machines. RMI itself was a groundbreaking feature that made distributed computing accessible to Java developer. So let's see a small class example also. So here, as you can see, RMI made distributed computing feel almost natural as calling a local method. The complexity of a network communication, marshalling parameters, and handling remote exceptional exceptions was largely hidden from the developers. This was a huge leap forward for building distributed systems. Now let's talk about internationalization support. So it also came in Java 1.1, which was comprehensive and forward thinking. Java introduced the concepts like local and resource bundles and Unicode support that made it possible to build application for a global audience. So this was all about Java 1.1 and 1.0. So this might look like a little less interesting or little less informative for as per talking about the latest features, but the old or very senior developers, engineers that would be very much happy with this video, because this might ring some bells on how life used to be and how life has changed for the betterment for the program in the programming world. So my main aim was not to jump directly to the latest features, but to show you the progress, how the progress has been made over a period of time in the Java language. Thank you for watching my video. Please help me grow this channel. Please subscribe, comment. Thank you.